Okay, this is a video about looking at number patterns from diagrams and working out the nth term formula to work out certain features of those diagrams. So if we have a look at this first example, this first GCSE question, we've got some patterns there being formed by grey tiles and white tiles. We've got white tiles in the middle and we've got grey tiles around the outside. And this is pattern number 1. Pattern 2, pattern 3, pattern 4. Okay, and the question says how many grey tiles are needed to form pattern N. Now what they're really asking us there is what is the nth term formula? Because if you want to work out a term in position N, then you need the nth term formula, and all N stands for, remember, is the position, which is why it's called nth term, because most positions end in th. So we could have 4th, 5th, 6th, 7th, 8th, 9th and so on. It's only 1st, 2nd and 3rd that have different letters after the position number. So they are just asking us for the nth term formula that we could use to work out the number of grey tiles in this pattern. Okay, so what do we need to do? Well, we've just got diagrams and we've got pattern numbers. Well, our pattern numbers are basically our position numbers, aren't they? 1, 2, 3, 4. The first diagram, the second diagram, the third diagram, the fourth diagram, and so on. So, like we've done before, that would be our N number, our position number. So 1, 2, 3, 4. I'm going to create a table, and underneath here I'm going to put G for the number of grey tiles. Now the number of grey tiles in pattern number 1 or position 1, we just need to count them. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 tiles. Let's count them in pattern 2. We've got 4, 6, 7, 8, 9, 10, 11, 12, 13. So I check that again. 4, 5, 6, 7, 8, 9, 10, 11, 12. I thought I didn't count it correctly. It was worth double checking. How many grey tiles in this one? Well, we've got 5 across the top, 5 across the bottom. That's 10, 13, 16. And how many grey tiles in pattern 4? We've got 6, and 6 is 12. And then 2 lots of 4, which is another 8. That's 20. Okay, so this table represents the number of grey tiles for each pattern. The first pattern, the second pattern, the third pattern, the fourth pattern, which is basically our position number. And if you look, it's just a standard linear sequence. Okay, so what we need to do now is work out the nth term formula for that number pattern that we've got there, just like you've done before. Okay, so what's the first thing we do? We look at the difference and we double check first 3 differences: plus 4, plus 4, plus 4. So we know the number of grey tiles, G, equals 4 times the position number, at least, plus or minus something else possibly. So what do? We write our sequence that 4n gives us. So if I write n there, I write 1, 2, 3, 4, and write 4n. 4 times 1 is 4, 4 2s are 8, 4 3s are 12, 4 4s are 16. And then we write the sequence we want underneath that and compare. We want 8, we want 12, we want 16, and we want 20. So what do we need to do to 4n to get the sequence we want? We need to add 4. You can all see that, and you've all done brilliantly with the topic before that. So 16 plus 4 is 20. Let's double check. 12 plus 4 is 16. 8 plus 4 is 12. 4 plus 4 is 8. So this sequence here is 4n plus 4. And there's our formula. The number of grey tiles needed to form pattern N is 4 times n plus 4. Our nth term formula for the number of grey tiles that we can see in those patterns. So basically all you need to do, if you're presented with a series of diagrams that are following some sort of pattern, is write down some numbers from each of the diagrams relating to the item they want you to work on, in this case grey tiles. So I wrote down the number of grey tiles in each of the pattern numbers in each of the first, second, third, fourth, fifth and so on, 8, 12, 16, 20, and then you just work out the nth term like you've done before. Okay, so that's the answer to that question. Right, well I got one more below here. I'm going to drag this up. This is part B and a very similar question. So what we've got, it says patterns are made using small squares. Okay, we can see we've got a series of diagrams, and again they've named them pattern 1, pattern 2, pattern 3, but that's basically the same as position 1, 2 and 3. Okay, find an expression for the number of squares in pattern n. Now the expression is just this part of the formula. So the 4n plus 4, or the 3n minus 1, or the 2n plus 8, that's the expression. When we write g equals in front of it, then it becomes the formula. Okay, so you can write down the formula, you'll get all the marks, or you could just write down this part and you'll get all the marks because they've asked for the expression. But if you did write the formula, it wouldn't matter, they will give you all the marks. So what do we need to do? Create a table again. So as we've done before, n is our position number, and we've got 1, 2, 3. So we've only got 3 because we've only got 3 patterns, and the sequence, which I'm going to call S like we've done before, that we get from our 3 diagrams is the number of squares. Well, you can think of S being the number of squares if you like. Got 3 squares in first pattern, we've got 1, 2, 3, 4, 5 squares in the second pattern, and we've got 4, 7 squares in the third pattern. Now if you wanted to, you could probably work out, can't you, for the fourth and the fifth, what's going on. Plus 2. Yeah, it's plus 2, so that's going to be 9, that's going to be 11. So we just need to find the nth term for this number pattern, just like we've done it above and just like we've done before, and that will be the answer to the question they've asked us. So we know that we've got 2n first because the first difference will always be multiplied by n in our formula. Then we work that out and compare it to the one we've been given in the question and see if we need to do anything else. So it might be plus or minus something else. So let's have a look. Let's write n again. We've got 1, 2, 3, 4, 5. The sequence we've got, sorry, I shouldn't have written that. We need to write 2n is the sequence we got. So 2 times 1 is 2, 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 5s are 10. The sequence we've been given is 3, 5, 7, and we worked out the next two because we could see it was plus 2 all the time. So there's the sequence we want. Do we need to do anything to go from this to this? Of course we do. We need to add 1, and we double check. 8 plus 1 is 9, 6 plus 1 is 7, 4 plus 1 is 5, 2 plus 1 is 3. Lovely. So this is 2n plus 1. So expression, if you just want to write the expression, that's 2n plus 1, or if you want to write the formula like we've done in the past, then the formula is S equals 2n plus 1. Remember, you can use that formula now to work out number of squares in any pattern. In pattern n. N stands for any pattern. Could be the millionth pattern, could be the billionth pattern. Remember, we just substitute n for the position, or in this case the pattern number we want. So if we wanted the millionth pattern, wanted to know how many squares there were in the millionth pattern, you just put a million into that formula. Just plug it in, and we'd have 2 times a million plus 1, which would be 2,000,001. So that's how many small squares there would be in pattern number 1 million. Okay, so a quick recap then. Basically, if you're presented with diagrams like we have here in these two GCSE questions, you need to turn these diagrams into a basic linear sequence, and then you find the nth term like you always do for any linear sequence, and that will be the answer to any question where they want you to find pattern n, or in this case pattern n again there. Okay, anything where they're asking you for how many matchsticks, how many circles, how many squares are there in pattern n or diagram n, they're just asking you for nth term. Okay, so create the number pattern from the diagrams, work out nth term as you normally would. Alright, okay, thank you very much, hope that helps.